Think about the rainwater that drops on the surface, ground surface. Then it takes a number of routes. Some of it could be moving over the ground as the surface water. Some goes to the nearby creeks and ponds and lakes. Part of the water infiltrate into the subsurface and take different routes through pore spaces and cracks and fractures and all that. Hydrologists follow the journey of water as it's moving from one point to the next, because chemistry of water changes along its way because of its interaction with the rocks and minerals. So we try to understand this temporal and spatial variation in chemistry of water, and based on that we can tell a lot about what's happening in the surrounding area. Okay, so this will be our site 2 then. Okay, Beaver Creek site 2. I'm just waiting a few seconds to get the pH.
Here on the park we're sampling the surficial rivers as well as a few of the deeper drip points and lakes. So we collected some silent lake samples yesterday and we set up some drip points at Buffalo Gap the day before. Right now in the house behind you we're waiting for an elevator to come up with water samples from What the Hell Lake, which is about 500 feet below ground. With those samples, we're going to try to match them up with surficial samples and rain samples that we've been taking on the 3 main creeks that run all across this park behind me and that fall onto the ground and percolate throughout. And with that information, as well as some groundwater we've collected from some local citizens who have been kind enough to let us borrow their wells, we are going to be producing a mixing model to figure out where the water in those deep lakes is coming from and how it's getting there. We go over to the river sample, wherever that is, at our predefined sites or sites that we choose in the moment and write down for future research. Bring our little wide mouth container over there, dip it in the water. We take our TDS electroconductivity and temperature probe, stick it in the water. That tells us how much the water conducts electricity through the 2 probes right there, and it tells us the temperature. And from the conductivity we can calculate the TDS, which this does automatically for us. So we dip that in until it steadies out, gives us a reading. Then we dip in the pH meter, which tells us how basic or acidic the sample is. This also does temperature, but just to keep things consistent, we always use the blue meter for that. Then we take this, which is a very expensive piece of kit called a turbidity meter. Inside here, we have a vial, which still has the last sample that we ran in it. We rinse it out, fill it with the water in here to this white line. We line up this vertical line with a small arrow on the inside of this, close it up, turn it on, run the sample, and that tells us how much light gets through from this side of the machine to that side of the machine in a controlled fashion, essentially telling us how cloudy the sample is in a non-subjective way. Lastly, in the field, we use this, which is a dissolved oxygen meter. This tells us how much oxygen is dissolved in the water. We dip it into the cup as so, or if we're feeling adventurous, we lower it slowly into the river so that we can get more direct sampling there. That tells us how much oxygen is dissolved in the water, which can be affected by plant life and by how much the water moves, as well as the saturation percent, how much the water should be able to hold in normal conditions and how much it is holding, which can go over 100.
So we monitor the chemical evolution of the water as it moves from the surface down into the subsurface through different routes. The other objective that we have for the hydrology team is to characterizing the water isotopically. Okay, we're looking at the environmental isotopes, especially oxygen and hydrogen isotope. Based on the analysis, isotopic analysis, we can tell a lot about the movement of water in the subsurface, because isotopes can fractionate depending on the exact mechanism of water movement. The huge significance of this work is our student education, okay? Because every year we are involving number of students from UNI. So this is also a big learning from them, because we teach our students, earth and environmental sciences. So what else, better could you do than taking our students out to the field and involve them in sampling, and also involve them in chemical analysis of the water. That way they can see a clear example of why quality of water changes over time. Okay, and at the same time they will also know more about the unique environment of the Wind Cave system.